On behalf of my colleagues, I will be presenting results of our analysis of about 30 years of water quality data from Laguna de Bae. This work forms part of a book that we are currently preparing. These are my colleagues and their affiliations. Please be guided by the outline of my presentation. Laguna de Bae is the country's largest inland water body. It is classified by some as brackish, by others as a freshwater body. It is a multiple-use resource with agricultural, industrial, domestic, commercial, and even energy production uses, but primarily its largest economic use thus far is for aquaculture. The LLDA has been conducting routine water quality monitoring of the lake and its numerous tributaries since the 1980s, but regular chemical monitoring did not start until the late 90s. Numerous other groups, mostly academic institutions, have similarly investigated the quality of the lake and the water at various periods. However, the number of parameters measured, the protocols for sample collection and analysis, and the location and density of the sampling sites have greatly varied over the years. As early as 1973, the lake had been considered as critically polluted with regard to a number of parameters. One critical parameter examined was nitrogen, which during that period was estimated to be around 5,000 tons and have entered the lake from livestock and poultry mostly, followed by domestic sources, the Pasig River backflow, and from agricultural practices, particularly the use of chemical fertilizers and industrial sources. It was also believed that during that time, nitrogen, in complex interaction with light penetration, temperature, and lake turbidity, was the current critical factor that impacted algal growth in the lake. However, a few instances of algal blooms were also observed due to variations in other key parameters such as light and temperature. Despite the occurrences of algal blooms and the polluted state of the lake, it was reported that at that time, 1970s, Laguna de Bae was not yet at the final stage of eutrophication. By the year 2000, a waste loading study showed that the total input of nitrogen had significantly increased, and this time the major contributor has shifted to domestic waste. The rest of the nitrogen budget was modeled to have come from agricultural activities, industries, and other sources. It can therefore be said that Laguna de Bae has been actually polluted since the 1970s. The question therefore is whether or not it has reached the level of pollution where there is no turning back. This presentation examines how the water quality of the Laguna de Bae has changed over the periods from 1990s to 2018. Values for these parameters examined were compared with the DNR water quality guidelines published during the relevant years, 1990 and 2016. To provide spatial perspective to the data, the lake is also divided, as how LLDA does it, into 4 groups of monitoring stations: the West Bay, the South Bay, the Central Bay, and the East Bay. Data from the different monitoring stations were averaged per bay and analyzed similarly to assess seasonal and interannual variabilities. For data from 2000 to 2018, multi-year averages were estimated for each month of the different parameters to illustrate seasonal variability. Yearly data from 2000 to 2018 are more detailed, and hence their annual averages are presented here. For data from 1990 to 1999, only annual averages were made available courtesy of the Millennium Ecosystem Assessment Report published in 2005. These were added to the dataset from LLDA to compute for decadal average to highlight the key changes of the lake over the last 28 years. To begin, we present to you the data on biochemical oxygen demand. The graph on the left is the decadal average. The one on the right, as will be for the next few slides, would be first on the monthly variability for data from 2000 to 2018, and on the bottom is the interannual variability, and the lines, the horizontal lines, are for the different water quality guidelines set by the INR. The different colors in these bar graphs correspond to the different of the lake. I would focus more in the interest of time on the decadal changes that the lake has undergone. The decadal average indicate the changes in each of the Laguna de Bae's bays have undergone from 1990 to 1999, 2000 to 2009, 2010 to 2018. In the first 2 decades of monitoring, no significant movements in the values were recorded. However, a significant rise in the value from the early 2000 to the present is now reflected in the data in all the bays of the lake. No data for the South Bay is available from 1990 to 1999. Despite the seeming worsening trend, the absolute value of BOD are still well within the Class A standard of DNR's water quality guideline of 2016. So these are the water quality guidelines. For chloride, the decadal average clearly shows the consistent decline in chloride values values from the 1990s to the present. Initially, the East Bay contained significantly lower levels of chloride compared to the West and Central Bays. However, today, nearly all of the bays register similar values that cluster around 100 milligrams per liter. Again, no data for the South Bay is available from 1990 to 1999. Because of this huge decline in chloride contents, the waters of all of the bays of Laguna de Bay now fall within the standards for Class A or B waters. If we look at the seasonal variability, you would notice that in the years 2000 to 2018, chloride values tend to become elevated, especially for the West Bay during the summer months. In terms of dissolved oxygen values, decadal average likewise indicates sufficient oxygen concentrations in the water of the lake. Despite the apparently declining physical characteristics of the lake, it appears that its capacity to support aquatic life continued to be sufficient. Fecal coliform data of LLDA only spans 27 to 2018 as shown in the figure. For both years, the average count was well below 100 mpn per 100 ml, which is the limit for Class B waters, but higher than the required for Class A, which should be less than 1.1 mpn per 100 ml. The results are both quite unexpected and quite controversial, considering the shortage of septic tanks and treatment plants all around the lake and extremely elevated values of fecal coliform in the tributaries or in the rivers surrounding the lake. Several potential explanations have been considered by our group. However, in the absence of sufficient data, as such, this would be an interesting study for graduate students out there and would be a great help to understanding the behavior of Laguna de Bay. These are the graphs for nitrate. Decadal averages for nitrate indicate a continued increase over the past 3 decades. Nevertheless, the absolute values, as you would notice, still fall way below the upper limit even for Class A standards. Ammonia in the lake have already been registering undesirable levels since the 1990s, with the West Bay reaching a decadal average that falls in the Class D category back in the 1970s already. And no improvements in this parameter have been observed over the past decades. In fact, it has been continuously increasing, especially for the West Bay and surprisingly even for the Central Bay. pH, decadal averages of the different bays of the lake consistently register a tendency towards more alkalic values, with pH sometimes going above 8. There is, however, that interesting trend where pH values started to appear to cluster towards a more uniform signature in the decadal range from 2000 to 2018 of about pH 8.3 for all of the bays. In terms of phosphate, the overall range is between 0.001 for the Central Bay to 0.1744 for the East Bay, an overwhelming majority of which exceed the current standard of 0.025 mg per liter for Class C waters. Decadal averages consistently indicate elevated levels of phosphate in all of the bays of the lake, and the trend has not improved since the 1990s. None of the bays would pass Class C standards based on decadal values. For the decadal average in temperature, it is interesting to note that the West and East Bay remained relatively warm at averages close to around 29 degrees centigrade, whereas the Central and South Bays registered low annual averages for the decade 2000 to 2009. Despite that seeming drop in temperature for that particular decade, all the bays now register or cluster at values around 29 degrees of average temperature. In terms of total suspended solids, decadal averages for the West Bay was far worse in the 1990s than it is now. That may indicate some decrease in the amount of sediments in the bay over the past decades. In contrast, however, sediment fluxes from the East Bay appear to have worsened. The Central and the South Bays are also exhibiting slow but definite increases in TSS from 2000 to the present, similar to the East Bay. Decadal averages for total nitrogen during the 1990s were significantly lower than they have turned out for the next 20 years. So they average around 0.75 to 1 in the 1990s and quickly rose up to around 2 and has been consistently high since then. Total N for the different bays have started to also significantly deviate in values relative to each other, with the higher values for the Central Bay and the lowest values for the East Bay. Chlorophyll A is an important parameter being studied now for the lake. Decadal averages for the different bays of the lake showed very interesting results. In the 1990s, the West, South, and East bays all registered total counts of about 20 to 30 mpn, whereas whereas the Central Bay had a relatively high decadal average of about 80 mpn, indicating higher productivity in that region. However, chlorophyll A values began to average out across the bays from the 2000s, and TCs of around 55 mpn and rising to about 100 something over the last few years. Since then, chlorophyll A from here steadily increased, but still with very close values from all across the bays. Based on decadal averages, the entire Laguna de Bay exhibited nearly uniform turbidity levels, but variations started to manifest in the 2000s up to present. In general, the East Bay appears to be the most obvious in terms of a worsening trend, whereas all the other bays are slightly improving relative to this parameter. This is a summary of the values for those parameters. What's important to note here is that in terms of the water quality guidelines being used by the DNR, in terms of several parameters, the lake actually would exhibit characteristics that would pass Class A standards on some seasons, but in other seasons, in their worst conditions, they would breach the D- level. The lake cannot be considered on a per parameter basis. Therefore, as a whole, the lake has actually been polluted since the 1970s, but has continually deteriorated over the last few decades, reaching very serious pollution levels that breach quality standard for Class D. This table shows the percent annual change in terms of lake quality parameters. The values compared the interannual changes in the water quality parameters to determine which ones are getting worse over the years and which ones are improving. Values in red are significant at 5% alpha. So if you notice, positive values for BOD indicate slightly worsening conditions, but there is some good news in terms of dissolved oxygen. Chloride has significantly changed over the last few decades, and this is the percent annual change for the different bays. Ammonia, likewise, is one of those parameters that has continuously worsened over the last few decades. And productivity in terms of chlorophyll A has also been changing significantly over the last 30 years. Limnologists have always classified lakes according to their trophic state. They can be classified as oligotrophic, mesotrophic, or eutrophic. The trophic state is a useful means of classifying and describing the lake process in terms of productivity systems. It is also attributed to the condition of the succession or aging in a lake. One way of representing the trophic state of the lake is by utilizing the method developed by Carlson that is based on the productivity of the water body. Carlson's trophic state index is a quantitative measure of the degree of eutrophication of the lake. It was utilized in our work to calculate indices through a combination of turbidity readings, depth, total phosphorus, and chlorophyll A parameters to determine temporal and spatial trends in the lake 2000 to 2018. Based on the 19-year data, the resulting TSI values of the lake for the assessment period ranged between 60 and 90. This translates to trophic levels between eutrophic and hypereutrophic. The high concentration of nutrients is the direct impact, we believe, of cultural eutrophication, which symptomatically manifest in the frequent proliferation of algal blooms that lead to fish kills. Extreme rates of eutrophication can considerably reduce the life of a lake through algal blooms, water quality deterioration, and sedimentation. TSI derived from chlorophyll A values are considered to best represent the trophic state of a lake, although combining TSI values derived from nutrients can also provide a more comprehensive view of the state of the lake. TSI chlorophyll values show that the lake can be classified as being between mesotrophic and eutrophic most of the time, with some dips toward the oligotrophic during the wet season. The presented TSI shares the same idea in looking at the biological response to factors such as nutrient addition, seasonal patterns, mixing, among others. So, what are the key points from our work? Some parameters are more telling than others, and these parameters need to be prioritized to avoid further degradation of the lake and to improve its current state. In general, these parameters include BOD, turbidity, phosphates and nitrates, ammonia, and fecal coliform. The lake is currently vacillating between eutrophic to hypereutrophic states. We use several models. I only presented the one from Carlson. Hence, this vital resource is truly in crisis, even based solely on the physicochemical parameters presented. There are other important pollutant or emerging parameters that need to be considered. That includes heavy metals in the sediments and in the water column of the lake, endocrine disruptors, and microplastics that should be further investigated, especially because the current knowledge on the extent of their influence and the gravity of their impacts are developing research fields. But we are mandated by the precautionary principle to look into this further with stringent regularity. Thank you very much.